Okay, so, oh yeah, okay, hello and welcome. I think I've updated the title appropriately. So, yeah, back to learning Java. So that I like live streaming this stuff. I don't know, something about it. It's interesting to me. So here we go. So we're gonna keep going from where we were yesterday. Not expecting to get too much time in today. I don't know how far we'll get. I guess we did 10 problems the other day, so hopefully 10 problems today. That would put us pretty close to the mark. We got how many problems left? We got 30. Less than 30, 28 problems. All right, see how we do. Okay. In this problem, you have to add and multiply huge numbers. These numbers are so big that you can't obtain them in any ordinary data types like a long integer. Use the power of Java's big integer class to solve this problem. Okay, well this is kind of easy. I mean these are intended to be easy, but I think so. They'll probably give us digits, right? Two numbers A and B, 200 digits, two lines A plus B and A times B. Okay, fair enough. And then so it should be as simple as just a big integer. Or we could do this way: string s equals. We'll do A. We'll do it that way. Next, and then B. Presumably that'll work, and then we can say big integer, big A. Yeah, B. And then we're going to say, don't actually know what this will do, but we're going to try it. Okay. Probably won't work. We'll try it. Okay, yeah. As I thought. More likely than not, they don't have those operators supported on for the big integer class. All right. Divide and add. Should be an add somewhere here. Add, yeah. Additions, big A dot add big B. Multiplication. And then we're going to take addition to string. Okay. Yeah, it looks like you can print a big integer directly, and you don't necessarily need to convert it to a string. All right, let's go for it. Yeah, it's kind of an easy question. Okay, it's good. It's good to have the knowledge. Sweet. According to Wikipedia, factory is simply an object that returns another object from some other method call, which is assumed to be quote-unquote new. In this problem, you were given interface food. There are two classes, pizza and cake, which implement the food interface, and they both contain a method getType. The main function in the main class creates an instance of the food factory class. The food factory class contains a method getFoodString that returns a new instance of pizza or cake according to its parameter. You were given the partially completed code in the editor. Please complete the food factory class. Okay, not too familiar or comfortable with this, but we're gonna try it. So what does this mean? Solution main, do not terminate, forbid exit. Try creating the factory, food factory is new factory, food is food factory to get food. Okay, I think I understand. You give a parameter and it'll get a certain kind of food. Food.getType, food.getClass, unsuccessful termination. Exit trapped exception, extend security exception, serial version UID 1, forbid exit, security manager, check permission, exit VM. Were people closing the VMs on Hackerrank? They were causing the something about that's really funny. Oh boy. Hackers, the hackermans. I don't know what's good what that is, but I'm assuming they put that there for a reason. That's pretty funny. Okay. Food factory, end of get food method, end of factory class. Okay, so it's the get food method that we're writing here. Interesting. What, excuse me. So if you have pizza or cake according to its parameter, I think I understand. Okay, I get it. Factory. So you give a parameter and you get a class, an object of a certain class, with the depending on that parameter. Fair enough. I don't really like that personally as like an idea. It seems kind of just seems like an extra layer of like it's almost like a hash map of strings to classes, but like you could just name your excuse me. It's interesting. I was just had a video where I was talking about how much I've not been sick. Excuse me. Man, the irony of lying to people, telling them that they're going to get sick and die, and then telling everyone you need to enact laws so these people who are afraid of getting sick and dying that you just lied to about them getting sick and dying, get them afraid so that way you can justify doing wicked things in their name. That's really evil. Just realized there's a lawyer that did that recently. It's like, what kind of monster? Anyway, so, all right. So we just use a switch statement, I think works. We're going to switch on order, and we're going to say case default. This one is cake. And this one's pizza. Yeah, the spacing is kind of messed up a bit, the tabs, but that's all right. We're not going to get too into that. So yeah, I mean, you just return cake object, a new cake object. And this new cake object is just a new cake object. Default. Didn't really give it like yeah, we're missing a return statement. Unreachable statement. I guess it's just a regular food item. I don't know. I could do this. Use a anonymous class. So get type. This food doesn't exist. Anonymous food. Someone ordered anonymous food. Can food be ordered a? Someone ordered an anonymous food. Alright, let's try that. It's always a return statement. Really confused what's going on. Oh, unreached, really? So no break statement. Well, I don't think it's an error. I think it's a. Is it an error or just a warning? Well, they're calling it an error. Huh. Okay. Sure. That's interesting. Alright. That's fine. Java Singleton pattern. Singleton pattern is a design pattern that restricts the instantiation of a class to one object. This is useful when exactly one object is needed to coordinate actions across the system. Yeah, fair enough. It's kind of like a monolithic thing, though, not just Singleton, but I guess in some cases you just need one sort of static class that's static. Well, I guess it wouldn't be static, I don't know, just one instance. It's a little bit different from having everything be static variables and whatnot. Complete the Singleton class in your editor, which contains the following components: a private Singleton non-parameterized constructor, a public string instance variable string, write a static method named getSingleton instance that returns a single instance of the Singleton class. Once submitted, our hidden solution class will check your code by taking the string as input and then using your Singleton class to print the line. Not be handling any input in this challenge. You will not be producing any output in this challenge. Sample input hello world. Hello world, I am a Singleton. Let me say hello world to you. What are we doing? We're private Singleton non-parameterized constructor. A private non-parameterized constructor. Okay. So, sure. There you go. Public string instance variable str. Is it static? No. Static method named getSingleton instance that returns the single instance of the Singleton class. I don't know how this is going to be checked. I'm so confused. Oh, the string is public. Okay, I think I get it. Turns the single instance of the Singleton class. Okay. And really you should have a private member here. That's the Singleton really is what it is. Really, you'd say something. You want to set this to null, I think, for the null pointer. Something like this. Oh, I see. Okay. It's single instance, not singleton. Oh, it works. Yeah, that's the basic idea. You have a static private singleton reference, and then you set that reference. The first time you call it, call this instance, you set the reference and create the object, and then every time you call after that, you can just return what this is referencing to, and that's it. So it constructs the object on the first call, and then the rest of the time you get the new one. I thought this is so clever when I first learned that you could do this, like years ago. It's such a simple thing, but I don't know, when I was younger it just seemed so clever. Anyway, don't know why exactly. It's not that clever really. All right. This problem, you must not generate any output on your own. Any such solution will be considered as being against the rules. Its author will be disqualified. Oof. Disqualified. I don't really understand what this means. Output of your solution must be generated by the uneditable code provided for you in the solution template. Oh yeah, that was, I did that before. An important concept in object-oriented programming is the open-close principle, which means writing code that is open to extension but closed to modification. In other words, new functionality should be added by writing an extension for the existing code rather than modifying it and potentially breaking other code that uses it. This challenge simulates a real-life problem where the open-closed principle can and should be applied. Yeah, fair enough. A tree class implementing a rooted tree is provided in the editor. It has the following publicly available methods. GetValue returns the value stored in the node. GetColor returns the color of the node. GetDepth returns the depth. Oh yeah, solid. There we go. Interesting. Returns the color of the node. GetDepth returns the depth of the node. Recall that the depth of a node is the number of edges between the node and the tree's root. So the tree's root has depth 0, and each descendant node's depth is equal to the depth of its parent node plus 1. In this challenge, we treat the internal implementation of the tree as being closed to modification, so we cannot directly modify it. However, as with real-world situations, implementation is written in such a way that it allows external classes to extend and build upon its functionality. More specifically, it allows objects of the treeViz class, a visitor design pattern, to visit the tree and traverse the tree structure via the accept method. There are two parts to this challenge. What is a visitor design pattern? Object-oriented programming and software engineering, the visitor design pattern is a way of separating an algorithm from an object structure on which it operates. The practical result of this separation is the ability to add new operations to existing object structures without modifying these structures. It is one way to follow the open-closed principle. In essence, the visitor allows adding new virtual functions to a family of classes without modifying the classes. Instead, a visitor class is accepted that implements all of the appropriate specializations of the virtual function. The visitor takes the instance reference as input and implements the goal through double dispatch. Whoa. Don't know if that really helped explain things. Special form multiple dispatch and a mechanism that dispatches a function call to different concrete functions depending on the runtime types of two objects involved in the call. In most object-oriented systems, the concrete function that is called from a function call in the code depends on the dynamic type of a single object, and therefore they are known as single dispatch calls or virtual function calls. How to use double dispatching in Smalltalk, calling it multiple polymorphism. Dude, why are things so complicated? Excuse me, multiple dispatch. Okay, is there more explanation here? General problem addressed is how to dispatch a message to different methods depending not only on the receiver but also on the arguments. Okay, excuse me, systems like CLOS implement multiple dispatch, double dispatch, another solution that gradually reduces polymorphism on systems that do not support multiple dispatch. I don't really get it. Multiple dispatch. Some programming languages in which a function, I mean, at what point does this just become like function overloading? You know, that's the thing I'm confused about. Function or method can be dynamically dispatched based on the runtime type, or in the more general case, some other attribute of more than one of its arguments. This is a generalization of single dispatch polymorphism where a function or method call is dynamically dispatched based on the derived type of the object on which the method has been called. Multiple dispatch routes the dynamic dispatch to the implementing function or method using the combined characteristics of one or more arguments. Use and practice, I don't know, dude, it's just confusing. I should say I don't have enough like experience of that to really comment on that too much. But why did that come up? Takes the interface instance reference as input and implements the goal through double dispatch. Oh, that is just confusing. Objects that are easier to implement, change, test, and reuse. The design pattern is one of the 23 well-known GOF design patterns that describe how to solve recurring design problems to design flexible and reusable object-oriented software. That is, objects that are easier to implement, change, test, and reuse. What problems can the visitor design pattern solve? It should be possible to define a new operation for some classes of an object structure without changing the class. It should be possible to define a new operation for some classes of an object structure without changing the classes. When new operations are needed frequently and the object structure consists of many unrelated classes, it's inflexible to add new subclasses each time a new operation is required, because distributing all these operations across the various node classes leads to a system that's hard to understand, maintain, and change. Yeah, I feel like I would need concrete examples for some of these things to really grasp them, to understand what they're talking about. It's really abstract right now. We're talking about what solution does the visitor design pattern describe? Define a separate visitor object that implements an operation to be performed on elements of an object structure. Clients traverse the object structure and call it dispatching operation, except visitor on an element that dispatches delegates the request to the accepted visitor object. Visitor object then performs the operation on the element, visits the element. This makes it possible to create new operations independently from the classes of an object structure by adding new visitor objects. See also the UML classes sequence diagram below. The gang of 4. Oh, that's what it means. Okay. Gang of 4. Sure. Finds the visitor as representing an operation to be performed on elements of an object structure. Lets you define a new operation without changing the classes of the elements on which it operates. Nature of the visitor makes it an ideal pattern to plug into public APIs, thus allowing its clients to perform operations on a class using a visiting class without having to modify the source. It kind of reminds me of like an operator, an iterator rather, just like, I don't really understand. How is this different from iterators? Maybe this is before iterators were a thing, but it seems like you can just have iterators through like some kind of a data structure, and then just iterate through it and operate on that iteration. I don't know. Moving operations into visitor classes is beneficial when many unrelated operations on an object structure are required. The classes that make up the object structure are known and not expected to change. The new operations need to be added frequently. An algorithm involves several classes of the object structure, but it is desired to manage it in one single location. An algorithm needs to work across several independent class hierarchies. Still not really fully understanding what we're looking at here. I think I really need to think about this for a while to kind of get it. I think I need some more concrete examples too. Drawback to this pattern, however, is that it makes extensions of the class hierarchy more difficult, as new classes typically require a new visit method to be added to each visitor. Use case example, consider the design of a 2D computer-aided design system. At its core, there are several types to represent basic geometric shapes like circles, lines, and arcs. The entities are ordered into layers. At the top of the type hierarchy is the drawing, which is simply a list of layers plus some added properties. A fundamental operation on this type hierarchy is saving a drawing to the system's native file format. At first glance, it may seem acceptable to add local save methods to all types in the hierarchy, but it is also useful to be able to save drawings to other file formats. Adding ever more methods to saving into many different file formats soon clutters the relatively pure original geometric data structure. A naive way to solve this would be to maintain separate functions for each file format. Such a save function would take a drawing as input, traverse it, and encode it into that specific file format. As this is done for each added different format, duplication between the functions accumulates. For example, saving a circle shape in a roster format requires very similar code, no matter what specific roster form is used, and is different from other primitive shapes. The case for other primitive shapes like lines and polygons is similar. Thus, the code becomes a large outer loop traversing through the objects with a large decision tree inside the loop, querying the type of the object. Another problem with this approach is that it is very easy to miss a shape in one or more savers, or a new primitive shape. Well, that's a good example to kind of think about. Or a new primitive shape is introduced, but the save routine is implemented only for one file type and no others, leading to code extension and maintenance problems. Okay, I have to read that again. I think I have to read this whole thing again, this example. Instead, the visitor pattern can be applied and encodes a logical operation on the whole hierarchy into one class containing one method per type. In the CAD example, each save function would be implemented as a separate visitor subclass. This would remove all duplication of type checks and traversal steps. It would also make the compiler complain if a shape is omitted. Another motive is to reuse iteration code. For example, iterating over a directory structure could be implemented with a visitor pattern. This would allow creating the file searches, file backups, directory removal, etc. by implementing a visitor for each function while reusing the iteration code. Oh, okay, I think I understand. So the iteration actually is not part of the, oh, I see. Okay, it is related to iterators, but it's, the idea is that you're not iterating over and over. You're actually writing a visitor function that you will iterate, and the visitor function will execute on, I guess, each data point, something like that. I don't know. It's kind of confusing because you kind of lose some, you lose a little bit of you lose some flexibility there if you can only view each data element as a single element rather than like as a data point in the middle of some portion of the data structure. In other words, if you said like, okay, we're going to I don't know, add every third element in our iteration. I mean, I guess that you could have maintain some state internally in your visitor function, like you have a static variable or something, or just some variable that gets set that between, depending on what the visit code is doing. But I don't know. I guess what I'm trying to say is like, you don't have, yeah, you just, I don't know what use cases there are exactly offhand, but I know not having access directly to the iterator and its sort of relative position makes things more challenging. Definitely, like there are definitely some things that are harder to do if you don't have access directly to the iterator itself. Something like that. Something like that. I don't know. So let's reread it. I'm trying to understand, but I don't know, I'm kind of struggling. So consider the design of a 2D. Excuse me, because you could, I mean, you could just reuse your iteration code. You know, like you don't necessarily need to arbitrarily restrict yourself from having access to that. Like you could write your iteration code as a function that takes a visitor, and then define your visitors in your functions. If that makes any sense. Okay. Consider the design of a 2D computer-aided design system. At its core, there are several types to represent different basic geometric types like circles, lines, and arcs. The entities are ordered into layers. And at the top of the type hierarchy is the drawing, which is simply a list of layers plus some added properties. A fundamental operation on this type hierarchy is saving a drawing to the system's native file format. At first glance, it may seem acceptable to add local save methods to all types in the hierarchy. Fundamental operation on this type hierarchy is saving a drawing to the system's native file format. Right, at first glance it may seem acceptable to add local save methods to all types in the hierarchy, but it is also useful to be able to save drawings to other file formats. Adding ever more methods for saving to many different file formats seems clutters the relatively pure original data structure. Geometric data structure. Yeah, so okay, so if every geometric object has a save method for each file format, then you get a lot of different functions in your data structure, and it becomes like flooded with file format saving methods instead of geometric data structure methods. A naive way to solve this would be to maintain separate functions for each file format. I think that's probably the right thing to do, actually, is to have each file format has its own, like that's probably how I would program this in C++. I would probably have free functions that are like, save some structure it takes as an input, and then it has like a file format, I guess as a class or something, and it'd be sort of generic code, and then depending on the file format, it'll take different steps. Depending on the data structure and the file format, you'll have different steps in your sort of your generic function, and then just use generics probably for that. But and free functions, so it's not really related. It's not really anything connected directly to the geometric data structure. So that's So separate functions for each file format. Such a save function would take a drawing as input, traverse it, and encode it into that specific file input. Right, exactly. As this is done for each added different format, duplication between the functions accumulates. Yeah, I guess so. Is that necessarily a problem? For example, saving a circle shape in a raster format requires very similar code no matter what specific raster form is used, and is different from other primitive shapes. Yeah. So saying some code will be duplicated, I guess what they're arguing, which I don't really understand how they came to that conclusion, but I'll assume that. And is different from other primitive shapes. Yeah, I guess. I don't really know. I'm not really following. The case for other primitive shapes, like lines and polygons, is similar. Thus, the code becomes a large outer loop traversing through the objects. I think I understand. So let's say we did what we were just describing, right? So we have some layers, some data structure that represents the picture, right? I guess it'd be sort of a picture class. and then there would be a file format class, and then we have our generic code that's going to, our template code that's going to loop through each object, each geometric shape on each layer, and then save that layer in a particular format for that shape. And I guess what they're saying is that, well, each of those layers has a different shape on it. Each of those shapes has different code associated. So you'd have to have like sort of a switch statement between each different shape. And I would argue you also could have sort of generic like rasterized code, or generic iterating code, or generic or templated rasterization code, or yeah, different pieces, saving each geometric piece. And I guess, yeah, you'd have a specialization for each one. But I guess, so they're saying there'd be a large outer loop that traverses through the object with a large decision tree inside the loop, querying the type of the object. I think that's fine. You know, I think it's okay. You have a sort of a switch statement between each object. Excuse me. The rasterization code is specific to each object. Let's call it rasterization. Each shape. And the file format, and they're saying it's this, so actually the file format's very similar no matter what specific raster form is used. It's not the same, it's very similar. I mean, I don't know. I mean, if you're using templates, I mean, you can kind of, some things could be specializations. You know, you can specialize, like you can write a subroutine. Like you can write templated subroutines that take certain objects, and you could specialize on those objects. So you have different code where you need it for those objects, right? For like a circle would be different than a line and other polygons, right? Although, actually, yeah, some shapes. I mean, even those shapes, though, you probably could generalize or specialize, I guess. Even those shapes, like polygons themselves, have kind of certain properties, I guess, no matter what shape you're making out of the polygon. I don't know, kind of rambling a little bit here, but I think this doesn't sound too bad, even with templated code. I realize it does get complicated, though, the saving code, or it could get complicated. Code becomes a large outer loop traversing through the objects. It doesn't have to be. I mean, you could just, like I said, you could have templated code where like, you already know what the object is, and you already have like the rasterization code is specialized for that particular shape, which is also could also be templated, and so it's not really a large outer loop. It's actually just kind of a yeah, I don't know. Like there's this kind of there's almost like a switch statement that's built in to, like, if you're doing object-oriented programming using switch statements, like your dispatch is kind of like uses a switch statement to figure out which object you're working with and then which code you should associate with that object. But the programming language itself has like function names that you can associate with object names, and it's kind of like that switch statement, instead of it being inside of a function, which is what they were just suggesting, like this decision tree, it could actually be part of the like inherent hash map structure you have, where you have function names associated with certain functions. Because that's kind of what you have just in code in general. You have a function name, and then it's attached to a certain function. Well, you can parameterize or template your function such that you have a different function for the same function name, but if you have a different object, then it does a different thing based on that object. And you have specializations you can write if you need to. If it's really different, if it's mostly the same though, then it's just part of the template. And you can even go so far as to write to template subroutines of that function, where those subroutines then can be also specialized as needed. So you can really get a lot of all the flexibility you need. Because ultimately you have to write code for all these different pieces, right? Like it's not like I don't think this design pattern, or naively or not, is necessarily like, I think you can have poor design patterns, but I do think like templated free functions, really you have enough flexibility such that you only write the code you need, and you can just write templated subroutines as needed as well, and their associated specializations, and then these things can all be like sort of abstracted away from each other into different pieces, and so they're not dependent. So then like the geometric code, like if like not including any extra code in the geometric data structure, and just giving the geometric data structure as an argument to templated free functions, like I think it's fine to solve a problem like this. I think so. I don't know. Maybe I'm wrong, but I'm just kind of pondering like what they're describing, trying to understand it, how I would approach it without, how I probably would approach it. Excuse me. Thus, the code becomes a large outer loop traversing through the objects, with a large decision tree inside the loop, querying the type of the object. Maybe potentially. Another problem with this approach is that it is very easy to miss a shape in one or more savers, or a new primitive shape is introduced, but the save routine is implemented only for one file type and not others, leading to code extensions and maintenance problems. Just thinking the approach that I just described, actually you would have compile time errors immediately if you don't implement all the pieces that you're trying to, because it's like I said, it's templated, so you just won't have, the code won't be available. It won't compile. The symbol won't be found if you don't implement the parts you need to implement. So yeah, or there'll be sort of like defaults, I guess, automatically generated defaults. It's kind of what I was describing. If you have specializations or not, if you need a specialization, I guess you could forget things in that sense. For new types, I don't know. I feel like forgetting is like a hard thing to yeah, can you make that a compile time error? Well, kind of. I don't know. I actually don't know about this one. What I just described, I don't think necessarily solves this. Because each shape really would have generic code, and then if you forget the specialization of that code, if it needs it, then yeah, then you're going to have a problem. And that would be something of a runtime error. Basically, it won't save the way that you're expecting it to save. So when you open it again, it won't look right. I don't know. I guess forgetting things is like, how do you protect against that? It's like, well, compile time errors would be good, but I don't know. Saving a circle shape in raster, other similar code becomes a large outer loop. So this is the naive approach. is to have separate functions for each file format, and then it takes the drawing as an input, and then there's each layer, so then there's duplicated code, saving a circle shape and a raster format requires very similar code no matter what raster form is used. So I guess for like a circle shape, all the different file formats, you would have sort of the same code over and over again, copied over and over. And it's different from other primitive shapes. And then the same thing for other primitives. You sort of have copied code over and over again. I mean, again, templated code is fine, you know, and you can, like I said, you can template a subroutine if it's sort of the same across multiple function names. Thus, the code becomes a large outer loop traversing through the objects with a large decision tree inside the loop, querying the type of the object. Another problem with this approach is that it is very easy to miss a shape in one or more savers, or a new primitive shape is introduced. Very easy to miss a shape in one or more savers, or a new primitive shape is introduced. So I think what they're describing here is if you had like a giant switch statement, basically, and then each of those switch statements did different things depending on the file format. And so you have like duplicated code all over the place, and then you could miss a shape in your giant decision tree. Something like that. I think that's what they're describing. Or a new primitive shape is introduced, but the save routine is implemented only for one file type and not for others. Right. So you can miss a save routine, or you can miss a... So basically what they're describing here is that you have sort of like a multi-dimensional function going on here where you have multiple combinations of multiple types of things. So different file formats with different shapes. That's really it, actually. It's just, you just have a sort of a cross product of these two. You have a very large set of functions to consider. It's sort of a cross product of these two different I guess object sets, and so your function would take a geometric shape and a file format, and each geometric shape is different from each other, and the file formats are different from each other, and so you have this cross product of templated. You can use templated code to do this, but these different functions, and so you end up with a decision tree. That's what they're saying. The drawing itself also, it makes things a little bit more complicated because we're not talking about just geometric objects and their associated and the possible file formats you could have for each object, but you also have a drawing which has layers of multiple objects, so it actually becomes even more complicated. But I think this particular part you can kind of isolate as like saving functions of just geometric shapes and the file format you want it to be in, and sort of selecting two different parameters and what those functions might look like, and having all that duplicated code because you now have potentially a lot of you have like a function for each sort of point in that Cartesian product is maybe the way to think about it. So you have a lot of functions and there's a lot of duplicated code across those functions. I think that's kind of what they're getting at here. So the visitor pattern can be applied. It encodes a logical operation on the whole hierarchy into one class containing one method per type. In the CAD example, each save function would be implemented as a separate visitor subclass. This would remove all duplication of type checks and traversal steps. It would also make the compiler complain if a shape is omitted. This really doesn't seem to manage the problem, though. I mean, it doesn't really seem to say very much about the problem. One method per type. A whole hierarchy. Yeah, it's kind of confusing. I mean, you can separate this into really two problems. All right, what I was saying was the shapes in there, a function that manages the shape. It has two parameters: the function, the shape, and the file type. And then the drawing, I guess, would use would probably when you're looping through the entire drawing, you probably would employ those save functions somewhere along the way. Which is maybe what they're saying here. I don't know. I'm a little confused. It's a little confusing what they mean by whole hierarchy. Into one class containing one method per type. In the CAD example, each save function, like this doesn't really make sense because you still need to have, each of those methods still need to properly operate on each of the geometric objects. In the CAD example, each save function would be implemented as a separate visitor subclass. This would remove all duplication of type checks and traversal steps. Would it though? Like wouldn't, what does that mean? I don't understand. Like how, okay. It would also make the compiler complain if a shape is omitted. I don't really understand. I think I need even this example to be a little bit more fleshed out. Another motive is to reuse iteration code. An example, iterating over a directory structure could be implemented with a visitor pattern. So something I really don't like about authors and just writing in general and learning in general is like, there are some things that are true, but you can't understand what they're saying from what they've written, right? So there are things that are true, but you can't understand what what they mean by what they've written. You can learn what they meant in another context and then bring that information to the thing you're reading. But when you do that, you might be able to understand what they're saying because you learned it somewhere else, but that defeats the purpose of what the person wrote. In other words, they're trying to convey it to you in the first place, not depend on your ancillary understanding from somewhere else, which you then bring back here, right? Like that doesn't make any sense. Like it's supposed to be, yeah, kind of something I really don't like about writing is that, like reading other people's work, is that if you're trying to understand what they're talking about, a lot of times you can't understand from just what they've written. I think that's a very poorly written article. And I think this is a good example of that, where it's not that you can't, but it's challenging to understand it from the perspective of somebody who doesn't have any other context to work with. That's something I've noticed a lot in just reading over the years, like reading different textbooks and things about, they try to describe a topic, but it's just really poorly written. Like it's just really poorly done, poorly explained. It doesn't really convey the meaning in the first place, right? Like without more context. So yeah, like this I don't really understand, right? I actually don't understand what they're talking about. I have to read it a bunch of times to try to guess it, what they mean. Iterating over a directory structure could be implemented with a visitor pattern. This would allow creating the file searches, file backups, directory removal, etc. by implementing a visitor for each function while reusing the iteration code. I mean, you could reuse iteration code in other ways too. I mean, you could just have a routine that's like, anyway, all right. Okay, I'm trying to understand, but I'm struggling. I'm struggling to understand what the point of this is. I think I need examples. Right, here we go. Okay. Let's do a C++ example. Smalltalk. Interesting. Smalltalk looks a lot like Toml, the way that's written. Anyway, so okay, abstract dispatcher file accept abstract dispatcher forward declare specific elements files to be dispatched, archive file, split file, extracted file. Abstract dispatcher dispatch to each of these files. Archive file, split file, extracted file, dispatcher, dispatch each of these. Dispatching. I'll be blunt, I don't really see how this, like, don't see how this explains the concept, and it just seems kind of unnecessary or not ideal. I shouldn't say it's not necessary. I think it's so basically someone was explaining a while back, I was reading about like the open close principle. I want to say it's the single responsibility principle. Like, no, it's possible to violate, I guess, dependency structure. Like, you want to have as few dependencies between your classes as possible. It's possible to violate that principle, which I guess would be like the single responsibility principle. Violate that while also also trying to pursue the open close principle. I want to say something like that. There's this tension between different programming designs where, like, for example, the problem with what we have here is, one, you need to declare a whole class for every one of these, which I guess is okay, but you might have a lot of duplicated code doing that. That's one thing. And the other thing is that now all of these are related to each other in that, first off, like, if you change the file class at all, it modifies all of these. That's one thing. And the other thing is, so they're all related now in that sense. They're all related to the file class. They're also all related to the abstract dispatcher in that anytime any of these are changed, you may have to modify, not necessarily the abstract dispatcher, but the dispatcher class, I guess it would be. If you change any of those. And then you also have, there's all these different interconnections between the functions and the methods and the classes. Like, what needs to change? If you change one thing, how many other things does need to be recompiled and changed as well? Certainly, if you add another class, right? You add another element. Not only do you have to build that element, but you have to add it to the abstract dispatcher. You have to add that to the dispatcher. Now has to be recompiled because it uses the abstract dispatcher. You have to add it here as well. There are all these different spots you have to add and modify your code. So I think it's not that this isn't what they call the visitor class. I think it's just that it's not a particularly, in my opinion, probably not the best design pattern to use because it has quite a lot of maintenance requirements because of the interconnections between these different pieces. I think actually the archive file, split file, and extracted file is probably a good example of open close principle in that you don't expect to modify the file at all class, and then so that way you can just subclass file, and then add extra functionality to the archived file. That doesn't change the original file properties. Yeah, also list-conf substitution, right? Where you want to have anywhere you could have used a file object, you could also use an archived file object. It doesn't modify the file behavior, which I don't think it does, right? I think it's the same behavior. Interesting. So, like, what does this do? So you have a dispatch for every one of these, references one of these files, overloads for each kind of file, and then you have an abstract dispatcher, and then you make it concrete by defining these functions, these virtual functions, dispatches on each file. And what do you do though? Just as prints out. But there's an accept, right? Yeah, what does this accept do? Calls the dispatcher's overloaded function corresponding to extracted file. So create the files, put them in an array, create a dispatcher, loop over each file, call the accept function of the file with the dispatcher. So every one of these has an accept function with a dispatcher, and then this calls the dispatcher dispatch this, which gets overloaded. I mean, that's just confusing, quite frankly. That's just confusing. Why go through all this extra effort? Like this function itself doesn't need to be. I mean, this itself is just duplicated code, right? I mean, basically anything that you could just say anything that implements this interface or something could have could just call this accept. What is this? I'm so confused. So this accept uses this visitor, which is the dispatcher, which then visits, does something different depending on what the type is, and the accept really just forwards the type to the dispatcher. I mean, that's pretty much what's happening here. It's just using single dispatch to forward depending on the type, call a different dispatch method from the dispatcher, which is, well, you register those different methods here. I mean, is this really, do you really need all this instead of just like some templated code that takes two different templates variables? One of them is the file, and the other one is like, well, actually, really, it would just be the file for a lot of these, because you only have one function that you're calling, which is just the dispatch function. I don't know, man. This doesn't seem too meaningful to me, in my opinion. Why do you need to do all this? But this is definitely duplicated code. I mean, you could just put this as like you really could do like you could put just a dispatched file class that has this function defined, and then you don't need these archive file, split file, extracted files, and then well, I guess, okay, I think I understand. Oh, I guess that's why they did it this way, is that they wanted to give each name a different type, and then you have this sort of each type would then call a different dispatch. I don't know. I don't even know what I'm saying anymore. It's kind of confusing. I think it's really unnecessary, though, it seems. Yeah, I mean, you could just specialize your templated code based off of each one of these. I'm a big fan of free functions, man. That's right. I think that's the way to go. Let's use free functions. I think it's better in general. Anyway, I think I get it. It's kind of, I don't know. It's like you're just kind of registering different types into a dispatcher, and then you're gonna have specialized code depending on the type. But that also gets registered somewhere else too. I mean, you kind of don't avoid that problem of like having to register your code in a few different places, register new classes. I guess you could do it this way. I guess. Must be implemented in all derived classes. Okay. But this really is just like a convoluted way of implementing polymorphism, where your function, your dispatcher, just selects a different function depending on the type. It's a pretty convoluted way of doing that, but that's ultimately what's going on here. Which again, you could just template your code and just do different things depending on what the type is. Yeah, you could just specialize your templated code. each time for the arguments, the parameters. And like I said, even the subroutines themselves can be templated in such a way where templated and specialized, where if you're trying to like have different pieces of the code that you don't want to duplicate it, so you can just run a subroutine which is also templated. Okay. Anyway, so interesting. I don't know. I don't think I really fully understand it, quite frankly. But I'm glad we learned about it a little bit. Yeah, okay. Implement 3 different visitors. Each class has 3 methods you must write implementations for. Get result. Return an integer denoting the result, which is different for each class. The sum in leaves visitor implementation must return the sum of the values in the tree's leaves only. Product red nodes visitor implementation must return the product of all values stored in all red nodes, including all leaves. Computed modulo 10 to the 9th plus 7. Note that the product of 0 values is equal to 1. What? Okay. Fancy visitor implementation must return the absolute. What am I? Okay. I'm sorry. I'm just. Okay. Sure. I'm here. I'm following. We're okay. Fancy visitor implementation must return the absolute difference between the sum of values stored in the tree's non-leaf nodes at even depth and the sum of values stored in the tree's greenleaf nodes. Recall that 0 is an even number. Visit node, tree node, implement the logic responsible for visiting the tree's non-leaf nodes such that the getResult method returns the correct result for the implementing class visitor. Visit leaf, implement the logic responsible for visiting the tree's leaf nodes such that the getResult method returns the correct result for the implementing class visitor. That's really awkward. Actually, both of these, if it's a true tree, if it's a true balanced tree, which it isn't necessarily, but suppose it was, then actually these 2 routines aren't too far from each other, because the number of children is roughly the same number of the number of leaves is roughly the same number of internal nodes. They're approximately the same, not exactly. I think they're off by 1, but they're almost the same size. So you really only are doubling the amount of computation if you split this into 2 pieces. So it's still O of n. It would be just O. It would be really O of 2n, where n is the number of leaves and n is the number of nodes. Excuse me. You just have a constant factor of 2 if you split these up, and basically run the same routine where you visit every node, but only consider the internal nodes and only consider the leaf nodes. Read in part 2, read and build the tree. Read the end node tree where each node is numbered from 1 to n. The tree is given as a list of node values, x sub 1 to x sub n, a list of node colors, c sub 1 to c sub n, and a list of edges. Construct this tree as an instance of the tree class. The tree is always rooted at node number 1. Your implementations of the 3 visitor classes will be tested on the tree you built from the given input. Oh, man. It's a lot to do here. It's just a lot of stuff. First line contains a single integer n, denoting the number of nodes in the tree. The second line contains n space separated integers, describing the respective values of x sub 1 to x sub n. Excuse me. Third line contains gonna hear some charging now, so hopefully it's not too bad, but you're gonna have it's gonna be like a small buzzing kind of sound here. First line contains a single integer n, denoting the number of nodes in the tree. The second line contains n space separated integers describing the respective values of x sub 1, x sub 2, and x sub n. The third line contains n space separated binary integers describing the respective values of c sub 1 to c sub n. Each c sub I denotes the color of the ith node, where 0 denotes red and 1 denotes green. Excuse me. Okay, so the colors are just green and red. Alright. Each of the n-1 subsequent lines contains two space separated integers u sub I and v sub I, describing the edge between nodes u sub I and v sub I. Okay, so I think I understand. So you have number of nodes in the tree, then you have a bunch of integers, which are the values of those nodes. Then you have a number of n zeros and ones, which will tell you if it's green or red for that particular node. And then also you have pairs of numbers, which give you the connections between the nodes, which will ultimately give you a tree. Okay, so you read all that in and you build the tree. That's fine. That shouldn't be bad at all. Do not print anything to standard out, as this is handled by locked stub code in the editor. The three get result methods provided for you must return integer denoting the result of the class's visitor. Defined above, note that the value returned by product red nodes visitors get result method must be computed 10 to the 9th plus 7 modulo 10 to the 9th plus 7. I kind of want to go like use the bathroom. Like stop here, take a break. Come back to this in a moment. Interesting. So also, what languages do I have for Java? What can we do more than this? Java 15. Whoa. Whoa. Lock stub code in the editor tests your three class implementations as follows. Creates a sum and leaves visitor object whose get result method returns the sum of the leaves in the tree, which is 24. Lock stub code prints the return value on a new line. Second, creates a product of red nodes visitor object whose get result method returns the product of the red nodes, which is 40. Stub code prints the return value on a new line. Creates a fancy visitor object whose get result method returns the absolute difference between the sum of the value of the non-leaf nodes at even depth and the sum of the values of green leaf nodes, which is 15. Locked stub code prints the return value on a new line. Okay, so you have three different visitor functions that are created. So you read and build this tree, and then you have these visitor objects that are created, and each of them have different methods, I guess, something like that. I'm not really sure. There's a get result, there's a visit node, and there's a visit leaf. Now, I don't really understand. Oh, well, I guess you have a get depth somewhere here too, right? Yeah, get color and get depth. So in your logic, I guess, when you visit the node, you can get the depth. And I actually don't know. Do we have to, when we build the tree, do we build the tree class? I don't know the depth too. I guess the depth, we have to set the depth and set the color as well, maybe? I'm not sure. There's probably okay. Excuse me. So we have these different methods for each visitor. So I think in theory each of these would be like, this is kind of like duplicated code. Solve. Oh, dude. This is a very, like, it's not a lot of, how does this relate to the visitor class going on here, explanation. It's just like, here's a bunch of methods, we're going to call some of them have fun. It's like, okay. There's different visitors, there's the root, solve, accept. It's not really solve, it's read and parse, or yeah, read and return, or read and parse is really probably what this should be. Get results for each visitor, and then print. I don't know about this. Doesn't seem like multiple dispatch or double dispatch going on here. Seems unrelated to the wiki article about the visitor design pattern. I don't know. Doesn't quite jive, in my opinion. What's actually being called here, though, is not to there's not a lot of code that's being called that constrains you to do things in a certain way. I also kind of want to take a break before I do this. Let me go to the bathroom. Let me take a break, go to the bathroom, start up a stream again on this problem, I suppose. The depth of the node, yeah. Here we go. Does constrain you a little bit, this tree class. That's what I was looking for. Tree value, color, depth. Depth, accept. Tree visitor. Tree node, tree, children. Tree node, value, color, depth, accept, visit node, add child. Oh, it's interesting. This tree is not a binary tree. It's more like a B tree. Not even a B tree. It's just a tree. Tree leaf. Interesting. Tree viz, get result, visit node, visit leaf. So that's an interface. And value, color, and depth. How do you find the root of the tree? That's a good question. When you read this tree in, does it tell you the root? Because it would be easier to define the depth. Actually, the depth is kind of hard to define too. That is in and of itself an interesting question of how do we actually set up this tree. You can add children, that's fine, but I think you need to build this up. Excuse me, I think you need to build the tree from the ground up, because you need to know the children need to exist in order to be added. You can add more children, but you need to know the depth. Right. So how does that work? I guess what you would do is loop over all of your, I guess I would create like temporary nodes and loop over all those nodes and just have a count of the, I don't even know. As far as reading things in, I think you want to read in the connections over the trees as the edges, I guess. and then for each node you can just count the, you can save the value, the color, and the number of ingoing or outgoing edges. And I guess you could find the root node. So I guess you could save like a tuple, like a temporary tuple of the data as you parse it, and then once you get you parse all that data, and then you can get the adjacency matrix, I get more or less, and then you can find which node has no incoming edges, and yeah, that's the root node. And then from there you can actually just iterate. You can do a depth first search from that root node to build the tree, and you can keep track of the depth as you go. So that's fine, but then that'll work. Then you can create the trees at that particular depth, and then add each of the children to that node, sort of recursively. Excuse me. So yeah, basically for every sort of in that adjacency matrix, all the nodes that all the nodes that are children, you can run the the recursion to get the tree node for that subtree, and then add that child, and then that should work. And so you can build the tree recursively. But then the question is, we want to implement these other routines, right? So I guess my question is, like, are every one of these going to be the non-leaf nodes, and every one of these are leaf nodes? Is this just duplicated code? That's one question. The other question is, how exactly do we want to write these routines? I guess what they're suggesting is that, like, you could write these visit node and visit leaf functions in a way that you only visit, they didn't really say if this is supposed to visit every node and every leaf in every case, or if you're supposed to write that in such a way that it only visits certain nodes, right? Because you could technically write your get result in such a way that you implement part of the visit node, but internal nodes and leaf nodes and what have you. I don't know. I mean, I guess it gets a little bit complicated at that point. Let me go to the bathroom though. Let's stop here. So it's been an hour and 20 minutes. We kind of looked at some things. Did not mean to open that. It's been an hour and 20 minutes. We looked at some things. We could probably pause here, and I think I'll stop streaming. And then what I'll do is I think if these problems are going to be like medium problems from here on out, then we can, well, actually I don't know, because it's a mix of like medium and easy problems, so I'm kind of comfortable, I guess, kind of lumping them all together and say, like, hey, I'm just studying Java, and then just kind of go through a bunch of different problems. So yeah, maybe I should maybe I should just use numbers to, like, day 1, day 2, day 3, etc. Just have learning Java and just say like 918 or something. So yeah, let me take a break. Thank you for watching. I will talk to you soon. I'll stop it here.